So the first thing you have to do is count up how many to make it happy, and then how many you have. And if you subtract those two numbers, it'll tell you how short you are, how many more electrons you would need to add. But you're not going to add electrons, you're going to bond. And when you bond, you count the same electron twice. You count it for one atom, then you count it for the other. So we have to divide by 2 because we're counting those electrons twice. So if you do this math, subtract to find out how short you are in electrons, divide that number by 2, it will tell you how many bonds there are. So if it comes up to 3, that your final picture should have 3 bonds in it. Could be 3 single bonds, could be a single and a double, that would be 3 bonds. Could be a triple bond. And you just draw in those bonds. And once you've drawn in all the bonds you did the math for, fill up the rest of the atoms. Make sure everything's full. Just draw enough dots to make sure everything's full. So you put the atoms down there, you put in the bonds, you fill everything up, and then to make sure you didn't just make it work because it worked, you have to check to make sure you have the right total. So in your final picture, you should have as many dots as your have number, because you have that many electrons. So if you have 16 electrons, your have number is 16. When you're done, you better have 16 electrons on your structure. So that's your check to make sure you didn't do something silly. Because you know everything's going to look like a noble gas because you made it look like a noble gas. So the question is, do you have the right number of dots there? Okay, I do not do this as my first choice. Okay, it involves math. This is more time consuming than the easy ones last night, but less time consuming than the hard ones last night. Does that make sense? Okay. So I don't always do it, but I'm going to do it with one we can do easily, so you see that the math really works, and how we can use it to tell us that there are multiple bonds. Okay, so we're going to do NH3 first. Do I need to do all this math to figure out how NH3 is going to fit together? Can you look at these pictures and see how it's going to fit together? Okay, so I'm not saying you have to do this, but we know what it's going to look like, so let's see how following this leads us to that picture we know we're going to get to. Make sense? Okay, so the have number for nitrogen is 5. It's in group 5A. The happy number for nitrogen is 8, because it would be happy if it looked like a noble gas. H, its have number is 1, got 1 dot. It'd be happy if it had 2, because then it would look like helium. The happy number is always either 8 or 2. So now we got the numbers we need, now we're going to do the math. Okay, so N has 5. H has 1, but there's 3 of them, so I've got to multiply that by 3. So when I'm done, the total number of dots I will have is 8. When I'm done, there will be 8 dots in my drawing, because that's how many dots I have to work with. That's how many valence electrons I have to work with. The happy number. Nitrogen would be happy with 8. Hydrogen would be happy with 2. There are 3 hydrogens. So 3 times 2 is 6. 6 and 8 is 14. So the N is happy with 8. The H is happy with 2, but there are 3 of them. So if everything was happy, I'd have a total of 14 dots when they were all separate from each other. But I'm going to put them together. So I subtract. 14 minus 8 is 6. Divide by 2. 6 divided by 2 is 3. This has 3 bonds. Now, from that number, 3 bonds right there, we can tell before we draw anything if there are multiple bonds in this. Okay? And here's how. Here's the idea behind it. It's not a very complicated idea. If I had 2 things, 2 atoms that I wanted to connect together, what's the fewest number of bonds I could use to hook 2 atoms together? It's the fewest number of bonds I could use to hook 2 atoms together. It's the obvious answer. 1, right? That's the fewest number of bonds I could use. Okay, if I had 3, what's the fewest number of bonds I could use? 2. If I had 4, what's the fewest number of bonds I could use?
2.
To hook them all together? The fewest number I could use to be, well, that doesn't, 2, 3, it takes 3. To hook 4 things together, it takes 3 bonds. To take 5 things together, it takes 4 bonds. Notice the pattern here? That there's always, that the minimum number of bonds is always 1 less than atoms. So if I have 10 atoms, the fewest bonds I can get away with is 9. In my example, I have 4 atoms, 1 N and 3 H's. What's the fewest number of bonds I could get away with? With 4 atoms, the fewest I get away with is 3, right? My math says I'm making 3. That means they're all single bonds. I don't have any extras. Does that make sense? I don't have any extras. So 4 atoms with 3 bonds tells me that they're all single bonds. Because 3 bonds is what is the minimum. 3 bonds is what I have. So I'm going to have the minimum. Notice we have not talked about these pictures over here at all. We don't need to. We need to do the math. We're doing something completely separate. Now we're ready to start drawing pictures. First, we draw on the bonds. There's my 3 bonds. Nitrogen hooked to 3 hydrogens. And I knew the hydrogen had to be hooked to the nitrogen because hydrogen's a dead end. Right? Hydrogen's a dead end, so everything's got to be hooked to nitrogen. 2 hydrogens can't be hooked to each other. Yeah? Then I have to put in the rest of the dots. How many more dots do I need? Do the hydrogens need any more dots? Does nitrogen need any more dots? Yeah, it needs a pair, doesn't it? It's only got 6, it needs a pair more. Okay? And now, how many dots are on the screen? 8. What was my halve number? My halve number was 8. I've got 8 dots. Everybody looks like a noble gas. I've got the right structure. See how it's different from the way we did it yesterday. Yesterday you would have built it atom by atom. Here we just boom, 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 threw the dots in first, threw the bonds in first. Okay. So, that was easy because it was all single bonds. Let's make it a little harder. HCN. Hydrogen cyanide. Smells like almonds. Then you die. It's cyanide. For right now, I'm telling you that C is the central atom, but that's going to go away as we learn more about how these things are built. Okay, so I can do my math. So the N we did last time was 5 and 1. Has 5, wants 8. We did that on the last example, so we're okay there. The carbon. Carbon's in group 4A, so it has 4. It's not hydrogen, so it wants 8. The hydrogen has 1, wants to end up with 2. Okay, with where I'm getting these numbers from. They're not random things. They're how many dots you would draw and 8 and 2. Luckily, there's one of everything, so the math is really easy. The halve number is 5 plus 4 plus 1. That's 10. 5 for the nitrogen, 4 for the carbon, 1 for the nitrogen. When I am done, I better have 10 dots on my screen. You should have 10 dots on your paper. That's what that's saying. The happy number, 8 plus 8 plus 2. 8 for carbon, 8 for nitrogen, 2 for hydrogen. That's 16 and 2 is 18. Subtract. 18 minus 10 is 8. So we are 8 electrons short. We're going to count those same electrons twice, so we divide by 2. And that means I'm going to end up with 4 bonds. So when this picture is drawn, there will be 4 bonds. What's the fewest number of bonds I can get away with? Well, how many atoms are there? H, C, N. There's 3 atoms. So the fewest number of bonds I can get away with is 2. I have to draw 4. I've got 2 extras. There's going to be multiple bonds in this. Not only do I know there are going to be multiple bonds, but I know they're not going to be on hydrogen. Hydrogen can't make a double bond, right? So I got to put multiple bonds in, and as I'm building it, I know I don't have to worry about them going next to hydrogen. Hydrogen is going to make a single bond. So the fewest, I did the math, so the fewest I can get away with is 2. I have to put in 4, so I've got 2 extras. So I put in the bare minimum. There's my 2. That's the fewest I can get away with. Those are the 2 bonds. The hydrogen hooks to the carbon hooks to the nitrogen, because C was central. Now, I have to put in the extra bonds. I got to put in 2 more bonds, because we said the total was 4. I've only put in 2. Where do they go? Well, if they can't go next to the H, there's not a lot of choices, is there? They got to go between the C and the N. So 1 bond between C and N is not enough. I need to make 2 more bonds. I need to make that a triple bond. Everybody see how I knew why that was triple? I had to add 2 more bonds. My math said so. So there's the 4 bonds. 1 single, 1 triple. 4 bonds. Okay, now I've got to make sure everything's full. The hydrogen, is the hydrogen full? Yeah, it's got its 2. Is the carbon full? Well, yeah, it's got its 8, right? It's got its 8 all the way around it. Oh, I can't believe I lost all those. So the carbon, we get to count all of those. So that's 8. Is the nitrogen there? Now, the nitrogen only has 6 next to it, just those 6. So I have to add more electrons to nitrogen. Oops. What the heck did that do? I jumped to someplace I have no idea. So I had to put these pair of electrons in. And if you count now, I've got 2, 4, 6, 8, 10 electrons, and my half number for this was 10. Okay, so we're going to have to put in extra bonds. We're going to have to figure out where those bonds go. And there's usually a better choice of where to put them. And the way I think about it is, how many holes do they need to have filled? I look at that atom and says, when that starts off, how many holes does it need to have filled? Because that's how many bonds it's going to try to make. How short of it is it looking like a noble gas? So if it's got 2 holes to fill, you can expect it to make 2 bonds. Hydrogen always makes 1 bond. Always. Because once it makes 1 bond, It's full. Hydrogen's a dead end. Okay, speaking of that dead end thing, okay, that means hydrogen can never go in the middle, right? Hydrogen can never go in the middle. Okay. Oxygen. Oxygen is in group 6A. It's got 6 dots and 2 holes. So oxygen should try to make 2 bonds if it can. Now, hydrogen will always make 1 bond. Oxygen, you try to find a way that it can make 2. If you can't, it might be possible that it hasn't. There are ways that it doesn't make 2. Usually with chemicals that aren't that stable, because oxygen wants to make more bonds. Nitrogen. Look at the nitrogen we drew today. How many bonds did nitrogen make? Well, in NH3 it made 3. In HCN it made 3. Because it's got 5 dots and it's got 3 holes. N should make 3 bonds. If you can find a way, have N make 3 bonds. Carbon makes 4 bonds. If you can find a way to make carbon make 4 bonds. Because carbon's got 4 dots. So it's got 4 holes. It's going to fill those holes by sharing. Shares 4 times. It's okay? Now, I'm not going to go through the whole periodic table. You should notice the trend about how to figure this out. And if you have, you'll be able to answer this question. How many bonds should sulfur form? Okay, you think about sulfur, you find it on the periodic table. You see it's in column 6A. You think of sulfur looking like this. How many bonds does sulfur want to make? There's a hole here and a hole there. It wants to make 2, just like oxygen. Oh, just like oxygen. It's like they're in the same column or something. Okay. Everybody see why sulfur wants to make 2? Okay. Which of these shouldn't make a double bond, should not make a double bond? You shouldn't make a double bond with one of these. The other ones can all make double bonds. Okay, just think to yourself. When you started chemistry and you were worried about the periodic table, you thought about memorizing it. Did you think you'd be using it to answer questions like this? Right? It tells you just by where it's at on the table how many bonds it's going to make. Lots of information on the periodic table. It's not letters or numbers. All about position, right? But how many bonds will nitrogen try to make? 3. Is 3 enough to make a double bond? Yeah, so it can make double bonds. What about phosphorus? Well, it's got 5 dots just like nitrogen, so it should make 3 just like nitrogen, so that's plenty to make 2 bonds. What about bromine? Bromine's got 7 dots. Okay? 1 hole. It only wants to make 1 bond. All the halogens are like that. The halogens are like hydrogen. Hydrogen's absolute. The halogens are only if possible. But they should make 1 bond. They should be dead ends. So you should never put a halogen in the middle. Okay? And an analogy, it's a little bit politically incorrect, but I got approval from somebody that it was okay to say this. Yeah? If you're playing a game of Red Rover, the one-armed person needs to be at the end. Right? You don't want the one-armed person in the middle of the game of Red Rover. Does everybody agree? I got approval from my student with 1 arm. She says, yeah, that's true. I need to be at the end. I don't want to be a weak link in the chain. Right? So something can only make 1 connection, you can't put it in the middle. Or you should try to avoid putting it in the middle. Make sense? Yeah, let's do, the other one was too easy. Let's try this one. This is hydrogen peroxide. Draw the electron dot diagram for hydrogen peroxide. The stuff you pour in your cuts and it foams up. Is a solution with a little bit of hydrogen peroxide in it. Because if you get a lot of hydrogen peroxide, it's rocket fuel. Literally. The V2 rockets were powered with hydrogen peroxide. Okay, now when I do my math, I like to be organized, so I make a table. So I say I've got to worry about 2 H's and 2 O's. And I got to worry about a happy number, and I got to worry about a have number. My happy number for H is 2, and I've got 2 H's. That's 4. My happy number for oxygen is 6. Oh, sorry, it's 8. Sorry, happy is 8. And I've got 2 of them. I was doing the math in my head, and my 16 was already in my head. That's what happened when I said 6. So my happy number is 20. If I was just filling up those atoms, I would put a total of 20 dots on them. My have number for hydrogen is 1, and I've got 2 of them. So that's 2 dots. My oxygen is 6, and I have 2 of those. So that's 12. 2 and 12 is 14. I subtract to find out how short I am. I'm 6 electrons short. I'm going to count those same electrons twice in a bond, so I divide by 2. And I find out this has 3 bonds. What does that tell me about H2O2? Well, how many atoms are in H2O2? 2 H's and 2 O's, that's 4 atoms, right? So the fewest number of bonds I could get away with 4 atoms is 3. I have 3. These are all single bonds. Okay? And now I have an idea about where to put them. Okay? Because I know the O's have to bond to the O, because H is a dead end. Now I have to go about putting on my H's. And how many bonds does oxygen want to make? 2. So once I hook that first hydrogen on, oxygen has the right number of bonds. So that oxygen is done. The other oxygen also wants to make 2 bonds. It doesn't matter where you put the bonds. This is not really what shape they are, just how they're connected. So if you notice that my bonds are in a way that everybody's got the right number of, I've got the right total number, 3, and each atom has the right kind of bonds, right number of bonds. Each oxygen has 2, each hydrogen has 1. Now I fill in the dots. The oxygens need 2 more pair. And my last check, how many dots are on that screen? 2, 4, 6, 8, 10, 12, 14. There are 14 dots on that screen. So I have the right number of dots. Everybody's got the right number of bonds, and everybody looks like a noble gas. A little bit longer than doing the bits and pieces part. But the math is not hard. You can't complain the math is too strenuous, right? You just got to multiply some numbers, integer digits. Okay? So that's hydrogen peroxide, how it's connected. That's its structure. Let's try it for CH2O. So I've got to worry about a C, 2 H's, and an O. Yeah, it won't let me write there. Stand by that spot. Okay. So my happy number for carbon is 8, for hydrogen's 2, for oxygen's 8, but there was 2 hydrogens. So I'm going to multiply that by 2. So my happy number is 8 and 8 is 16, and 4 more is 20. Or 8 and 4 is 12, and 8 more is 20. Okay. The have. Well, carbon has 4. Hydrogen has 1. Oxygen has 6. There's 2 hydrogens, so I got to double that. So 4 plus 2 is 6, and 6 more is 12. So when I'm done drawing this, I need 12 dots on this in my drawing. Are we okay with this? Subtract those numbers. 20 minus 12 is 8. Divided by 2 is 4. This has 4 bonds. What does that tell me about multiple bonds? Well, what's the fewest bonds I could get away with for CH2O? Well, CH2O is 4 atoms. So the fewest bonds I can get away with would be 3. But I have to put in 4. I have an extra one. This is going to have a double bond someplace. Okay. So now I go to hook them together. I know the H's are dead ends. So the C and the O must be hooked to each other. Those are my 3 bonds, the minimum. I have to put in a 4th. Where does the 4th one go? Where's the 4th one go? Can it go between the C and the H? Nope, it's got to go between the C and the O. And notice what that does. That gives each H 1 bond. It gives oxygen 2 bonds, and it gives carbon 4 bonds. Everybody's got the right number of bonds. Carbon's got 4, oxygen's got 2. Now I have to fill in the dots. This oxygen needs 2 more pair to look like a noble gas. The carbon's got 8 already. The hydrogens have 2. And if this is the right structure, then I should have 12 dots. 2, 4, 6, 8, 10, 12. 12 dots. Make sense? So let's see how that changes the ones those carbon and hydrogen ones that you worked with on last night's homework. You had some C2H4, H6, H2. So let's try something else with just carbon and hydrogen. C3H6. C3 means 3 C's, H6 means 6 H's. My happy number for carbon is 8, for hydrogen is 2. I've got 3 carbons, and I've got 6 hydrogens. So the carbons are 24 when they're happy, and the hydrogens are 12, and 24 and 12 is 36. Okay, where those numbers are coming from? If it's not hydrogen, it's 8. Okay, have. Carbon has 4. Hydrogen has 1. There are 3 carbons, so that's 12. There's 6 hydrogens, so that's 6. 12 and 6 is 18. 36 minus 18 is 18. Divided by 2 is 9. This has to have 9 bonds. Now, it has to have 9 bonds. How many atoms are there? How many atoms in C3H6? Well, 3 C's and 6 H's, that would be 9. What's the fewest number of bonds I can get away with? If I got 9 atoms, the fewest bonds I can get away with would be 8, right? So I have to put in 9, but the fewest is 8. I have an extra one. So before I draw anything, I know there's a double bond in here. And before I draw anything, I know the double bond has to be between the carbons. Right? Because it can't be on the nitrogens, or on the hydrogens. So let's draw in some bonds. So I'm going to hook those 3 carbons together, because that's got to happen. And I have to put a double bond in between the carbons, because the double bond can't go on the hydrogen. And I know it's a double bond because I've got to put in 9 bonds, and I only need 8. So there's 4 of my bonds. Sorry, there's 3 of my bonds. And when I hook on those 6 hydrogens, that'll be the other 6 bonds. I got 3 bonds, 6 more. So when I go to hook them on, I can hook a hydrogen here, hook a hydrogen here, and I can hook a hydrogen here. And that carbon's full. The next carbon already has 6 electrons next to it, so it only needs 1 more hydrogen before it reaches its octet, which leaves me 2 more hydrogens to put on that last carbon. And now everybody has noble gas configuration. I don't have to add any of those. Everybody's noble gas configuration. Everybody's got the right number of bonds. All 3 carbons have 4 bonds. All the hydrogens have 1 bond. Okay. Now the last thing we have to check, 2, 4, 6, 8, 10, 12, 14, 16, 18. There's 18 dots on there, which was my half number, 18. Do I do this every time? No. My first thing is, can I picture how they go together? If I can picture them going together, I do it the way I taught you before today. Because that's fast, if you can picture it. If you can't picture it, then it's time to start thinking about math. Make sense? So, like I say, just like trying to factor an expression. Okay? You can factor it, or you can use complete the square to solve for x, right? Use different ones on different problems because sometimes it's easy to complete the square, sometimes it's not. Sometimes it's easy to factor, sometimes it's not. You're not allowed to use math examples, Mr. Green. Okay. So the front side is mostly about general pieces. Talk about the pieces that you're supposed to learn to be able to do this. Okay. The back side, there's a lot fewer pictures to draw. Okay. There's not as many pictures as last night. We're going to be drawing these things for the next week or so, because once we get good at it, then we can start seeing what all these connections mean to us. What does this have to do with why I want to use soap when I do dishes? Do you have a front? Okay. We'll give you a full copy. Make sure everybody's got 2 sides. Oh, here, have a second side. There. Let's do some scratch work. Okay. So actually, the one I don't want you to struggle on here is number 6. Read number 6. How the heck are you supposed to answer number 6? What are the kinds and number of atoms in C5H10O4? The answer is 5 carbons, 10 hydrogens, 4 oxygens. People try to make it much harder than that. Because if you can't do that, you can't do the math. Right? You got to know what those subscripts mean. It really is supposed to be that easy. How many of each type? Okay. Number 8, I'm expecting to do the math for those.